Welcome back. In this lecture, we will learn to use Spark Structured Streaming API for ingesting data from a landing zone. We want to learn incremental ingestion from a landing zone or from a cloud directory using Spark Structured Streaming and ingest data into our bronze layer table. But we want to also implement automatic schema evolution. So let's get started. As usual, I'll go to workspace and show you one notebook where I have set up code for this demo and connect a cluster, do some cleanup, and then also do some initial setup. So that's all. We want to learn how to ingest data from a landing zone. So we need to have a landing zone directory. So I have simulated this landing zone directory here. The directory name is invoices. And I'm assuming that we ingested 3 data files. So my data ingestion tool is ingesting data from source and saving it as data files in the landing zone. The file format is CSV. And as of now, we have ingested 3 files. So now we want to build code to ingest data, these files from landing zone and build our raw data layer, bronze layer table, and load this data into the bronze layer table. How to do it using Spark Structured Streaming with schema evolution automatically. So I have set up a code here. Basically, I want to create a ingest function. Inside the function, we want to implement Spark Structured Streaming for reading data from the landing zone with configurations necessary for implementing automatic schema evolution. So let's see what do we have. So first thing is to set this configuration Spark SQL streaming schema inference. We haven't created our table and we are ingesting data from a CSV file. So we want to implement schema inference, automatic schema inference for the CSV file. But for Spark Structured Streaming, schema inference is disabled by default. It doesn't allow you to infer schema. So if you want to allow Spark Structured Streaming to infer schema from the CSV files, I'll have to set this configuration to true. So that's what I'm doing here. And then rest is simple. We are using a spark.readStream to read data from a landing zone. This is the location. We want to read it as a stream and create a streaming data frame. Format is CSV, and since CSV file comes with header, I'm specifying header is equal to true. And then we also want to infer schema automatically from the CSV file, right? So I'm setting that infer schema equal to true. And we want to make sure that we are able to read data from the files even if two files have different schema. So I'm setting this merge schema option to true. This merge schema option is for the CSV reader, which will allow CSV reader to read two data files even if there is a difference in the schema in those two data files. So that is the reader option, and read it from the landing zone, create a streaming data frame. Once we have the streaming data frame, we don't want to implement any transformation, any logic there. The idea is to load the raw data as it is into the bronze layer table. So next step, what we are doing, taking this streaming data source and using write stream, and all the automatic schema evolution is implemented at this place, right? So we want to write this stream as a delta table into this table at the end, right? Invoices raw, that's my bronze layer table. And usual options, since I'm writing a stream, it is always advisable to implement a checkpoint so you can restart from the same point. So this is my checkpoint location, and set the merge schema option while writing the stream. So this is what enables the Spark structured streaming to automatically evolve the schema of the target table. This is my target table. So if target table doesn't have those fields which I am ingesting, the stream writer will automatically add those fields into the target table. So setting this will enable my automatic schema evolution. Output mode is append, and we want to trigger the available now for only those files which are already available in the landing zone at the time of starting this streaming query. Run only one micro batch and stop, and then we will schedule this function to run at regular intervals, maybe every 5 minutes, half an hour, depending upon our requirement. So that's all. We have the code. Let me run it, and I'm making a call to the ingest function that I defined here, and once it runs, I should have data loaded into my target bronze layer table. So let's see, it worked. Now if I go and check my bronze layer table, I should have data. I have loaded 793 rows. That's what I have in my data files. So we are done with the first iteration. Now let's assume in the second iteration we ingested some more new files. So I have simulated that scenario also. I am copying one additional file into the landing zone directory to simulate that my data ingestion tool has ingested some new data into that directory. But this new file comes with some additional column. So in this file we have one new column coming in. What do we want to do? We want to implement automatic schema evolution. We want to keep on ingesting whatever new fields are coming, keep on automatically evolving our tables. So we are already configured for all that. So there is no code change required. Nothing. All I have to do is to call the same ingest function that I defined earlier and executed earlier. So I'll simply call that function. No code change is required. Nothing. It will work and ingest the new field also. So it's done. Now if you want to see your table after the ingestion, just look at it. We have a country column here. In the earlier ingestion, in the result table, customer ID was the last column. We didn't have country column, but now we got one more column. Data is there, looks null in the beginning, but in the later records we have the data. So data is ingested. If you want to describe your table and see if the schema has evolved appropriately, you can describe the table and see that you have a country column added, which is a string. So that's all. That's how automatic schema evolution works for Spark structured streaming, and that's what we wanted to learn in this lecture. See you again. Keep learning and keep growing.